Okay, good morning, everybody. I'm Dr. Jordan Gutterman, a professor of medicine at the MD Anderson Cancer Center in Houston and a trustee of the Albert and Mary Lasker Foundation. I want to welcome everybody to the 8th breakfast at Lasker.
So I'm John Ferdinand. I'm a PhD studying currently at the NIH, but between the NIH and the UK. And I'm interested in the tumor necrosis factor receptor superfamily of cytokines in immune responses. So my question is, sort of to all the Lasker winners, was there a key moment or a key experiment in your career where you realised we've got something really great here, or was it just a gradual accumulation over time and at the end sort of looking back and realising?
So the eureka moment, the aha. Yeah. Peter, you've written and spoke quite a bit about looking for the unexpected and when things don't make sense. Why don't you go expound on that?
I don't think it's luck. I think it's more serendipity.
Yes, I do.
So serendipity is when you find something you weren't in quest of. So discovery, and when you find something unexpected, you need to recognize it. And I think that's one of the things that happen in research all the time. And for us, these moments are really precious. And it's always when you walk down a road. You have projects where the next step is sort of the expected step. You have to convince the students to work on something, so you need to dangle a little carrot in front of them. But then the real excitement happens when something happens in the lab that it doesn't make sense. It's wonderful. It's a complete paradox. And whenever we have a paradox, I think we get really excited because when you can resolve it, when it's a really defined paradox that you know you just haven't switched the tubes or some fly dropped in and something random happened, but if it's a paradox that is well documented, then resolving that, the answer cannot be boring. Because the next morning, as you said, you wake up and the world has changed, right? Something new has happened. These precious moments of discovery.
My name is Jamie Solis, and I'm an MD PhD candidate in the NIH Oxford Cambridge program. I study molecular motor proteins, myosins. And so I guess my question is, after you've accomplished so much, you're at the Lasker Awards, about to receive your award in a matter of hours. What is it, looking back, that you're most proud of?
So for me, it's the people who've come through my lab and who are now successful on their own. And where I have the feeling that the lab has contributed something to their career that advanced them and gave them the self-security that they can do. So this is, I think this is the heritage that we all have, right? It's the young people we trained and who go on and take a little piece of the philosophy and the approach you have and start their own careers.
It's a kind of secular immortality.
Great. Mentoring.
But I'm not ready to look back yet. Fortunately, in this country, we don't have a required retirement age,
Right.
so we can keep looking forward. You're only as good as tomorrow's experiment. Now, Dr. Ben-Abed just did a 45-minute interview in English yesterday, and he was brilliant. So.
You're too kind. I think that in France it happens that we have a mandatory retirement at 65. As you can see, I'm close to 65, actually 7 years later. And that's still a possibility to continue. This is what I'm doing now. It's just to jump on the other trail. You know, it's like doing surf. When I was in California, they tried to teach me how to surf. And then you swim and you go through the first one, and then you just realize that it took you back. So when you are riding the surf, the ultimate thing is not to consider you are the winner, because you are going to crash anyway. So the good surfers are the ones who, at a given time, they just, by a little movement of the trunk, go back and catch the next wave, which is quite often better. So it's like this. If you have a mandatory obligation at a time, retirement or what else, there is another wave that you can catch and then continue. And there is no end on that. there is an end, but there is no solution for this one. So the rest is going on, and an achievement is never an achievement. It's the worst thing is to be the first when you're ranking, because your problem, when you're second, you still have a goal. I will be the first. If you are the first, the risk is to become the second. The only risk. So you have to continue. And I think that's for teams. The way I see the Lasker has been taken by my team now is wonderful. Now we know that it's possible to do something worthwhile. Let's continue. And that's very
French
very.
answer.
Kazutoshi, would you like to weigh in? What is most proud in your career, or do you have?
I took a chance. It's also in my remarks. When after graduating, I was in a department of pharmaceutical sciences. My seniors, most of my seniors went to a company, pharmaceutical company, but I want to stay on academia. And I hope to have academia, but at that time, Japan had no postdoc system.
Right.
We had a serious problem, over-doctor program. If you want to stay on academia, many PhD science waiting for the availability of position by doing part-time jobs. So I did not want to do that kind of thing, but very fortunately, I had a permanent position at a local university. I worked hard, but I did not enjoy that job. So I decided to quit that job and to go to the United States. It was a permanent job, permanent position. The people around me was worried very much. It's too much challenging, but I wanted to test my talent in science. Because I was not doing well at the local university, but it is because my no talent or the environment is not good enough. So I want to change the environment to test my talent in science. Right. If I'm talented, I could do well. But if I'm not talented, I stop science. That's a challenge. I took a chance and went to the United States. Then make the unfold protein response. And then I did well.
Yeah.
Probably I'm talented.
I think this is a very wise answer for the trainees to hear, that the willingness to take a risk is very important, and they need to be reasonable risks. You need to think through which are the right risks to take, but the openness to taking risks is important. Don't always take the safe
But also
road.
to take a risk outside of your own culture.
Yeah.
Is very dangerous. And I think every American should go outside of the States for a while, because it's so comfy to stay home. you
But
know?
science is learning new languages.
Exactly.
Discovery is learning new languages. I mean, you can't just stay in your field. You have to read. For example, Liam was trained as a physicist, and Peter was trained in chemistry originally. So these are new languages. You go from chemistry to biology. So this is kind of a paradigm from going to Japan to Dallas, Texas. And then part of the opportunity for you, because you had a great mentor.
I could trust myself a little bit more than normal people. So you should trust yourself.
Yeah.
Exactly.
Great answer. Great
Were your
answer.
parents?
Hi, my name is Stan Wong, and I'm an MD PhD candidate in the NIH Cambridge program. I'm in my final year of PhD before I return to the second half of MD at Columbia. And my research is in the general realm of stem cell biology, where we think we may have uncovered a novel master regulatory way in which stem cells are regulated in a very unexpected way that challenges some of our fundamental understandings of how stem cells become all the tissues in the body. In terms of my question, as many of us around the table are students and quite early on in our careers, if I may, want to ask the awardees to take a step back in time to your early careers. And I want to ask, what are some of the key decisions, key critical decisions you made early in your career? How did you make them? By talking to mentors, etc. And how did they define who you are today?
For me, I started in physics, got very fascinated with a world that I hadn't really thought much about till I got to the university, and history and language and all the other liberal arts sorts of things. Got then very interested in psychology and how the brain controls behavior, that, touching on some things, and ended up in medicine and neurology because to me that seemed like the most interesting thing. But if I think back, what really triggered those decisions, I'm not sure. It was kind of just trying a bunch of different things that were there in front of me and exploring them. And although I came from really hard science kind of thinking at first, I departed. But one key thing I saw was I took a biology course as a senior, and when I was decided to go to medical school, but I had never taken any life science. So this was a crazy kind of thing. But it was an eye-opener. It's just like a world that had been sort of covered up or never really studied. I mean, chromosomes divide, simple things were just like life is the most fascinating topic I think you can ever, focus on. So that was a turning point for me, and it really was. I mean, it reinforced everything. I was clear from there on, and then I had to think about psychiatry versus neurology and pure research versus a combination of things. But I think you just kind of follow your nose and you do what's interesting and never think about, money, or you can't never think about, but, do something interesting. Follow what really your brain is telling you, not your heart. I mean, your brain is telling you. You get into those metaphors. But I think the decisions, we think we make decisions, but I think things are being decided while we're thinking about what we want. We try to make it a very cerebral thing, like we can pinpoint exactly what it is. But I think it's the kind of experiences that you have and that those sort of subconscious sort of factors that drive you. But I mean, really do what you enjoy and pick the area. Don't grind away at something that's not going to pay off. Take chances and opportunities when they.
Does anybody else want to weigh on this one? Because all these questions are just profoundly interesting. We could spend the whole morning addressing this. Peter, you grew up.
Very short, but
yeah.
I think we can look back and we can say we made the right decision. When in fact it was just a meandering path. You make the best out of whatever happens. Right?
Right.
I think the main thing is never lose passion in what you do. I think the only guiding principle that I see. And don't give up if things don't. I applied for Rockefeller University for the graduate program and I was rejected. And then I stayed in on the waiting list. Applied for fellowships, grants get rejected, and so on and so forth. That doesn't mean failure, it's just a temporary thing.
Hi, I'm Peter So. I'm a second-year student at the University of South Alabama in Mobile, Alabama, a medical student, and it's an honor for me to be here. My question is, I was reading the Nature magazine interview, and I think competition was something that was asked about between a few of the researchers. And Dr. DeLong had mentioned that it wasn't really a big influence because there's more neurons than competitors. I think that was a great answer.
I think it was outnumbered by neurons.
Yes, yeah. And I think there was a degree of competition with Dr. Walter and Dr. Mori, which led to a collaboration. And so, do you feel that the competition was more efficient, and when you look back on it, to get your results faster, and or is there a good balance between the two? Is it an appropriate segue into collaboration?
It wasn't collaboration. Just we had a senior competition. Peter is already a famous professor. I started as a postdoc. Right? Huge difference. But we could get.
You're the most dangerous kind.
as the same molecule at the same time in 1993. And then I went back to Japan at that position. And we tried to get same thing, same factor. Then we got factor almost at the same time. And then we revealed how these two molecules are connected. It's a very unusual way to be connected. But I think, yes, it was very hard for me to keep up with major player. But I have nothing to lose. I'm a professor, I'm just a researcher, nothing to lose. Just keep going. Never give up. People say never give up. Keep going to trust ourselves we could do something. So just keep going. Unfortunately, I could survive. And then I became associate professor and professor. So just I wasn't too scared to against Peter. Just he's human too. he doesn't kill me. So.
Peter, you've written. I'm sorry. Go ahead.
We kept going. That's key. Never give up.
And Peter, you've written the competition has turned into a close friendship. You want to?
Yeah, I think competition doesn't mean that you have to be nasty to one another. It is simply that you're pursuing similar goals, and there is complementarity that comes out of that. And I think if you have too much communication, especially when a field goes through a bottleneck, after that it will expand anyway. There are many more questions, just like neurons, that come out of anything we learn. Right? We learn a little bit, and then we have more questions than we had before. So by having a more than one approach, I think the results become more complementary. If you communicate constantly, you're basically merging the ideas, and everything becomes the same. So I think it's a powerful contribution actually to have independent ways of looking at the problem, especially for students and postdocs in the lab. If you know precisely what's going on somewhere else, the grass on the other side of the fence always going to look greener, and everybody is going to think of, oh, maybe I should do what they are doing, and so on and so forth. And I think it worked out great.
Move the field quite rapidly.
Quite rapidly, yes.
Yeah.
Probably more rapidly than would have happened otherwise.
Very, very interesting.
I think the power of diverse perspectives is very important to embrace. And when we say that diversity of perspectives brings excellence, and excellence means diversity of perspectives and approaches and ideas and concepts, that's something to think about in your own research, who you're reaching out to. It's also important when you're thinking about building your research team. How can you bring together people, whether they're collaborators or team members, who will bring these new ideas so that you're always batting them around back and forth. And then you get great results like this.
Mary Claire had a point I think she wants to make.
I found the competition difficult. There's no question that it's real and it's not going away, and it's a huge part of our lives. And I think it is positive to the extent that centralization of science leads to massive collaboration in the absence of competition. I think we actually lose something exactly as you said. I've asked myself why I find the competition so difficult, and I think it's that when growing up as a girl in the 50s and 60s, we were not encouraged to compete. It was before Title IX. The only exposure I had to competition was in music. I'm a flutist, and in that sphere one competes every week for a chair, and you're constantly going through it. But I think for girls, I think the opening of Title IX, the opening of the academies, the opening of the world of men to us at a young age makes a huge difference, because competition then seems a normal part of life. It isn't something we have to suppress in ourselves. And you realize that you can be both competitors and friends, which is not something growing up that ever even occurred to me. I mean, and guys do this all the time. They compete with each other, but they're on teams together. And that has become so much more equal. I mean, I think we owe so much to Title IX. And so I celebrate that for all of you, that you can be competitive and you can be friends at the same time, and it's normal.
Hi, my name is Grace Liu, and I'm a senior at Stuyvesant High School. This summer, I just started dipping my toes into the field, I worked at a lab focused in metastasis at the Rockefeller University, and I was studying inhibitors of transcription. So my question to you guys is, well, I'm definitely the most novice one at this table, no doubt. So I just want to know, like, if you guys could, like, go back, talk to your 16-year-old, 17-year-old self, what piece of advice, like the most important advice, do you have for, like, your younger self?
Do whatever you want. That's all. Whatever you like. What is tempting to you? When someone asked me, why did you choose brain? I have an easy answer. What else? I always wanted to work on the brain. And then it happened that I had to choose during the medical studies if I would be a doctor or a physician or a surgeon. The surgeon is more active. A doctor, a neurologist has to ask, excuse me, Maman, has to ask the neurosurgeon to do something. The neurosurgeon does what he wants, sometimes what the neurologist wants. But that's kind of immediate freedom to act, that's it. And then you manage with what is available and what life brings to you. Go where you want to go. Easy.
So I will get the neurologist reply.
I think it's a difficult thing to put yourself back into 17 and then know all the answers, you know.
Right.
But I think when you're 17, you kind of think you might know a lot of the answers.
That's a guy thing.
Maybe you're right. Maybe you're right.
Yeah.
Yeah. So I was trying to get back in those shoes. I really had a good idea what I wanted to do. I sort of said I wanted to do physics, and I was really into hard science. I love math, and then I got exposed to things that I had never when I got to the university, and that were, you know, that was what was eye-opening to me, was how much diversity and fascinating things were going on. And I think the answer is, what do? You do what you really feel is most interesting and exciting, and opportunity is always part of that. You know, is this field really going somewhere, or can you make it go somewhere? But I think you do what you really think is most interesting. Interesting and fascinating is probably the important one.
You only have one life. Make it interesting.
Yeah, absolutely.
Okay, Mary Claire, what would you tell a 17-year-old girl, Mary Claire, in Chicago?
I think being a 17-year-old young woman is very, very difficult in all cultures at all times. And I think the most important thing is to believe in yourself. And you know how you remember the campaign a little while ago about bullying where the president says it gets better? It gets better. This is not about bullying, but it's the same thing. It gets better. And I mean, you're older now, and you've done very, very well. But no matter how crashingly depressing and terrifying it is, it gets better. And you need to believe in yourself. It's very different for us at 17 than it is for the guys. It really, really is a very unusual girl at 17 who's self-confident. There is biology out there, and you just need to believe in yourself and know it will get better.
Hi, I'm Elisa Moe. I'm an MD PhD candidate from Johns Hopkins, and my work looks at the different neuron subtypes in the brain and uses genome-wide technologies to look at different epigenetic patterns across neurons. So my question is the following. You guys have obviously had such amazing careers in science. But I'm curious, outside of science, do you have any interests or hobbies? I think Dr. King already mentioned that she plays the flute, that you've kept up throughout your scientific journey. And also whether the interactions or the experiences you've had outside of science have influenced what you've done in the lab.
I want to direct that to Peter to start with, because he's actually written about this and spoken about this.
Yeah, so I love art. I make sculptures, furniture. And it's a wonderful balance to the cerebral work that you do in the lab, to do something with your hands, to create things. And it's also connected in a way, because both in science and art you have to create new things. You have to think out of the box. It's not enough to just do the same thing that somebody else has done. In that respect, it's perfectly complementary, and I think perhaps uses different portions of my brain. And it's wonderfully rewarding.
And you're good at
One of the hardest things is finding time for all these other things
that's
that
why I
are so
built a
fascinating.
time machine.
The time machine.
It squeezes time and bottles it.
If we could shrink sleep, expand time.
So time you won't find, time you have to take.
But the brain, I'm going to weigh in on a question related to this. The data now, the science is showing that the brain, when it's resting, is really working.
Absolutely.
In a very creative way.
Yeah.
So that rest period, when you think you're not really working, you're creating. Could you all?
You know, I have this experience, I think probably everybody does it. There's a problem or something I can't quite solve, and I'm out in the yard pruning or something. Out of the blue comes, where did it come from?
Where did it come from? Exactly.
What was happening?
Right.
You know, I wasn't thinking about it. And then, well, I think this is such a common experience. And we know the brain is busy. And I do have that view, and I kind of hinted at it before, that a lot of the things that we think we do consciously and deliberately are really underground. You know, that brain is processing. And think about evolution. I mean, what did the brain have to do? Had to figure out how to predict, how to make decisions quickly, but also to weigh. And you can't go to sleep and survive. You know, and strategizing. So the brain is busy all the time.
Even during sleep.
During sleep.
Sleep
Yeah.
is important.
Oh, yeah.
So.
Sleep is more important probably than wakefulness.
Yeah. Yeah.
That's a good excuse.
But this is very important advice, because sometimes a problem that you're really up against that you can't solve, you think, I just need to work more and more and more on this problem, and that can be exactly the wrong thing. At some point, you sometimes have to let it go, at least consciously, and divert your attention to something else so that you're working on it maybe on a different level. But it comes back to the balance question that we were talking about before. So I think you can actually end up being more creative in your science if you have this balance of other activities in your life.
I agree. That's a good point. I want to ask, we'll have to be very brief here, but Kazuto Toshi, in Japan, do you find that you were here in the U.S. for a while? You know a lot about Peter's lab, how he works. Is there a difference in terms of quiet time, should we call it, leisure for scientists? Is there a difference in the cultures between how it works in Japan, as, let's say, compared to the U.S.?
Depends on, I don't.
No, there's no. Yeah, okay.
So
It's complex, isn't it?
I'm a kendo player. You know kendo? It's a Japanese martial art with protectors and bamboo sticks. I play kendo since I'm junior high school days, more than 40 years. And kendo says once match game starts, don't fear, don't get surprised, don't be scared. You stay on a normal condition, then do your best. So that helps me to fight against people.
Thank you.
Now you know his secret.
I did that before.
Hi, I'm Christy Campa. I'm a first-year PhD student in the NIH Oxford program, and my research area is in rod photoreceptor maturation and development. My question really, we've touched on it here and there, but so we've talked about persistence and like keep working even when things look bad, but then we've also talked about taking risks, and if something's not interesting anymore, going and doing that. So how, along your careers, how have you been able to discern when, if something just wasn't working, when you needed to keep chipping away at it and just be persistent with it, or when it was time to maybe cut your losses and just do something totally different and take that risk? Like, when do you know which to do? Because it's a balance.
You don't. You don't. You have to try it out, right? And sometimes when you have people in your lab and things go well, for others they don't. You never know whether it's a project or whether it's a person. So you just have to march along the road. But at the same time, opportunities open up.
Right.
And you take the opportunities. right? You branch out. So we start projects just explorative. If they go somewhere, if we get traction with them, we continue. If not, we still go to the next step with them. But they're more straight road. So the risk comes. It's balanced risk.
And you add them. You don't take away one and drop them forever. You add something else, and then you see which one's going best.
And in my role, we have the responsibility for the careers of people in my lab. So you cannot continue on something that just isn't producing for too long. It doesn't mean the idea was bad.
No.
So maybe somebody else is successful with it at some point in time. But then you build more projects that have tangible goals.
I want to thank everybody today for joining us, the winners to get up early after dinner last night, and all the students for a marvelous set of questions, a very stimulating conversation.